This video is to go over the Building Java Programs book, Chapter 8, which is about classes, self-check number 5, which is called Calculator Object, and we're going over this in the Practice It website, which is a free website that accompanies the book. So normally I don't bother having videos over these short answer problems, but I thought this one was interesting and possibly even misleading. So I thought it was interesting because it's very important, this topic of how you figure out what classes you're going to create and what data that class has and what methods are going to operate on that data. That is really the key to being a programmer. It's like an architect in a building. Being able to look at a problem and figure out what things you're going to use to solve the problem. It's very crucial. So I wanted to look at this. So let's not even look at these answers here. Let's just talk about it for a second. So we're going to create a calculator class, and it's going to be used to solve simple mathematical problems like you've used in math classes at school. So this calculator is going to be able to add, subtract, multiply, divide. And so you can imagine that what we need, it's kind of not the user interface, but the programming interface for this calculator object is we should be able to give it numbers, okay? And we should be able to perform operations on those numbers. That could take the form of having one function that just says compute, and it maybe takes the operator, add, subtract, multiply, divide, and 2 operands. Or maybe it has methods to give it the first number, a method to give it the second number, and a method to handle the individual operations, so add, subtract, multiply, divide. And you could probably imagine it's going to have a memory, so you probably want to store things and recall things from the memory. And there's probably a user interface too, so you want to actually display the stuff on a calculator. So if I wasn't even to look at any of these options here, I would probably design my calculator function to have individual functions for add, subtract, multiply, divide, and I would have a way to set the first operand and set the second operand, and then you call one of those multiplication, addition, subtraction, division, and then it would return the value. And I could have another method to store a value and to retrieve a value. That's probably what I would do. Now let's take a look at some of these are really kind of oddball ones that you can probably rule out pretty quickly. Here's one. The state is the number of calculators the user has ever used, and you create a new calculator, solve a new math problem. Each calculator can only be used once. So it kind of hints that that's a real waste to create a new calculator for every single time you want to add 2 numbers together, right? So that's not a very good option. The state is the list of every number the user has ever computed on the calculator. And the behavior is a set of commands for examining and manipulating that list, such as scrolling back and removing elements. That's actually useful, and there are calculators that do that. What's missing here, though, is a way of actually computing things, so that's not good. Here's one that be the state of the set of numbers on the calculator from 0 to 9, and so that's the state, okay, and then the behavior is all of the buttons on the calculator. So you can add, subtract, multiply, divide, and set, well, it says 7, but it's presumably all the buttons. So this actually is not a bad answer, and in fact, when designing user interfaces, some of you may have already experienced a user interface like this where you drag and drop buttons onto a screen and then you create functionality for those buttons, and that's object-oriented design, and that would actually work. But I think this problem is particularly getting more at less on the user interface. It's missing a few things here to fully make it clear how this would work. So if the state was the set of the numbers from 0 to 9, I mean, you would have to have it would have to be more than just the numbers 0 to 9, right? You would actually have to have a value. But it would be a good idea to have objects for each button, and a method on that button would be, to press that button, and then that would store some data in a larger object that would be the full calculator. So it gets into a more complex design, but actually in reality, if you really want to design a calculator and implement it in a graphical user interface, this actually would be part of it, okay? All right, here's another one. The state might include a number that's just been computed in a memory feature. Behavior might include methods to add, subtract, multiply, divide, so that sounds good. And perhaps advanced math, yep, that all sounds good. So this actually is a pretty good option here. Then here, calculator includes its name, who owns it, age, size, weight, all these different things. Behavior is what you can do with the calculator, lift it up, put it down. So if what we were doing was designing, you know, a Sims simulator, a Second Life simulator or something, you know, some sort of simulator of what people can do in a real world, then this would be an excellent explanation, because we wouldn't care so much about computing individual numbers. We just want the user to be able to pick it up and move it and stuff like that. But that's not this case. So really, this is the best option. But what I want you to get out of this is not so much this particular answer, but kind of the methodology of how you figure out what is the state and what are the methods. So think about how it's going to be used. Okay, sometimes it's better to think about what is the data and then think about what the methods are that would act on that data. Okay, in this particular case, I would say it's actually the reverse. You really want to think about what are the methods you're going to do. You're going to add, subtract, multiply, divide. You're going to store numbers, get them back, and then think about, well, what data do you need to be able to store that? And thinking back to what I originally came up with, which is you would have methods to do add, subtract, multiply, divide, etc. And also some methods to set what's the first operand, what's the second operand, and then it would store the value, etc. It's very close to what this is doing here because they're talking about keeping the number that has been just computed. I would say the state should really be what's the first operand, what's the second operand, that kind of evaluation. But this is as close as it gets. So if you've found this useful, please like and subscribe. I've got a complete curriculum on teaching Java through the Building Java Programs book.